Welcome, dear students, to another very important topic of the organic chemistry, and that is the beta elimination reactions of alkyl halide. Dear students, we have already discussed the types of the organic reactions, and we know that there are four types of the organic reactions: addition reactions, elimination reactions, substitution reactions, and rearrangement reactions. Now, elimination reactions are the reactions in which there will be removal of two atoms or group of atoms from two adjacent carbons. So, elimination itself means removal, and elimination reactions are those reactions in which two atoms or group of atoms are removed from two adjacent carbons. And as a result of the removal of these atoms or group of atoms, there will be loss of two sigma bonds and formation of one pi bond. The loss of sigma bonds and formation of pi bond shows that the saturated molecule will be converted to unsaturated molecule during the elimination reactions. Now, specifically, what we are going to discuss in this lecture, that is the dehydrohalogenation reaction of the alkyl halides. Dehydrohalogenation reactions are those reactions in which a hydrogen halide molecule is removed from the alkyl halide. So, dehydrohalogenation means the reactions in which a hydrogen halide HX molecule is removed from the alkyl halide, and after the removal an unsaturated molecule of the alkene is produced. Now, why they are called as beta elimination reactions? The letter beta shows that the base during the elimination reaction attacks on the beta hydrogen. Beta hydrogen is the hydrogen which is attached to beta carbon. Beta carbon is the carbon which is directly attached to alpha carbon, and alpha carbon is the carbon which is directly attached to the functional group. Now, these are called as beta elimination reaction because the base attacks on the beta hydrogen during these reactions. My dear students, there is a slight difference between base and nucleophile. During SN reactions, you come across the term nucleophile, but during elimination reactions, you see the term base. Basically, elimination reactions and substitution reactions, they both take place in different environments. You know that SN reactions of alkyl halides, they take place in the aqueous alkaline medium in the presence of an aqueous alkali, and the elimination reactions of alkyl halides, they take place in the presence of the alcoholic alkali, means alcoholic base. If you will dissolve a base in water, that will be the aqueous base, aqueous solution of that base, and if you will dissolve a base into ethanol, that will be the alcoholic solution of that base. So SN reactions, they take place in aqueous alkaline medium, and the elimination reactions, they take place in the alcoholic alkaline medium. So that is why a single species OH negative, that acts as a nucleophile in SN reactions, and that OH negative acts as a base in the elimination reactions. Now, nucleophile, what is the difference between the nucleophile and base? Nucleophile is a species which is electron rich and which prefers to attack on any atom other than hydrogen atom, while base is the species which is electron rich but it prefers to attack on the hydrogen atom. So if an electron rich species attacks on hydrogen preferably, that will be called as base, and if an electron rich species preferably attacks on any atom other than hydrogen, then that will be called as a nucleophile. Now, in elimination reactions, the electron rich species attacks on beta hydrogen, so it is attacking the hydrogen atom. So that's why in this case this electron rich species will not be called as a nucleophile, rather it will be called as a base. So this is the reason why the letter beta is used. Now, this one is a general reaction in front of you. Alkyl halide molecule, it is functional group, and the functional group is attached to this carbon which is alpha. This alpha carbon is attached to the carbon which is the beta carbon, and these two hydrogens, they are the beta hydrogens as they are attached with the beta carbon. The base which is taken from this KOH, this is OH negative, it will attack on the beta hydrogen, and the beta hydrogen will be removed in the form of H positive ion. H positive and OH negative will combine to form water, and then this halogen is removed in the form of X negative, and because of the loss of this halogen from alpha carbon and proton from beta carbon, a pi bond will be produced between alpha and beta carbon, and you will get an alkene. So there will be loss of two sigma bonds, one of this CX bond and the second CH bond. So there will be loss of two sigma bonds, and there will be one new pi bond that will be formed between two carbon atoms. Now, just like the SN reactions, the elimination reactions are also of two types. One are the E2 reactions and other are the E1 reactions. So let us discuss them one by one. E2 reactions are those reactions which are single step reactions, and as the E2 reaction is a single step reaction, so that single step will be the slowest step, and that will be the rate determining step. Now, my dear students, in this single step, the base, it attacks on beta hydrogen. It gives two electrons to the beta hydrogen, and this hydrogen is removed in the form of H positive ion. So OH negative and H positive, they combine to form water. Now this bond which is present between carbon and hydrogen, this one, both electrons of this bond, they are shifted here to form a pi bond between the two carbon atoms. And as the carbon can form maximum 4 bonds, so this carbon breaks bond with the halogen, and the halogen takes both shared electrons with it. As a result, it will be removed in the form of X negative. The shifting of this carbon hydrogen bond here, that will produce a pi bond between two carbon atoms, and you will get an alkene. So basically, this sigma bond and this sigma bond both are lost, and a new pi bond is produced. This is the dehydrohalogenation. From alkyl halide molecule, one X negative and one H positive is removed. So overall, HX, a hydrogen halide molecule, is removed basically. So this was the single step. Now, what is the molecularity of this reaction? Molecularity means number of particles or molecules that take part in the rate determining step. Now, in this case, there are two species which are taking part in the rate determining step. One is the base, second is the alkyl halide. As the two molecules take part in the rate determining step, so they will be the bimolecular reactions. What will be the rate law for E2 reaction? Rate law is written with respect to the slow step. So R is equal to rate constant, OH negative, which is the base, and Rx, which is the alkyl halide. It means that E2 reactions are those reactions in which the speed of reaction depends on the concentration of both base as well as the alkyl halide molecule. So these reactions are first order with respect to base, and they are first order with respect to alkyl halide, and overall they will be the second order reactions. The next point is the hybridization of alpha carbon. Now you can see the alpha carbon here, that is sp3 hybridized, but when it is changed to alkenes, now both these carbons, they are sp2 hybridized. So hybridization of alpha carbon changes from sp3 to sp2 in case of the E2 reactions. And the last point, what kind of alkyl halides show E2 reactions? You will say that all alkyl halides, they show E2 reactions, whether primary, secondary or tertiary. But E2 are most favorable with the primary alkyl halides. Mean the primary alkyl halides show E2 reaction with maximum easiness, and the tertiary alkyl halide, they show E2 reaction with the minimum easiness and maximum difficulty. So the order of the easiness is primary, most easily show E2, then secondary, and tertiary, least easily they show the E2 reactions. They are most reluctant to show the E2 reactions. Now let us compare the E2 reaction with E1 reactions. E2 single step reaction, but E1 is a two-step reaction, in which the first step is basically ionization of the alkyl halide, which is a slow and reversible step, and as it is a slow step, so it will be the rate determining step. While in the second step, the base attacks on the beta hydrogen and you get an alkene. So it is a two-step process. E2 was a single step process. This is the point one which shows the difference between E2 and E1 reaction. Now next point is that in the slow step of the E1 reaction, only one molecule of the alkyl halide, this is a tertiary alkyl halide, and specifically that will be tertiary butyl bromide. Only one molecule of the alkyl halide takes place. So as one molecule of alkyl halide is only taking part. So that's why we will say that these are basically the unimolecular reactions. So these are unimolecular reactions. These E2 are bimolecular, E1 are unimolecular. Now, how we can write down its rate law? As the rate law is written with respect to the slowest step, and there is only one molecule of the alkyl halide which is taking part in the slow step. So rate law will be R is equal to rate constant into Rx. Means the speed of reaction only depends on the concentration of the alkyl halide, and the speed of reaction does not depend upon the concentration of the base, as the base appears in the first step. So it will be a first order reaction. It will be showing first order kinetics, unlike E2 which are the second order. What is the change in hybridization? In first step, this alpha carbon is sp3 and it is changed to a carbocation, and you know the positively charged carbon of the carbocation is sp2 hybridized with 3 bonds. So hybridization in the first step changes from sp3 to sp2. Now look at the second step. In the second step, this base takes the beta hydrogen in the form of H positive. So OH negative and H positive, they combine to form water, and this bond between beta carbon and beta hydrogen, that is shifted between alpha and beta carbon, and you will get an alkene here. Specifically, this is 2-methyl propene. So in the second step, this carbon is sp2 hybridized, and both these alpha carbons, they are also sp2 hybridized. So you will say that basically in the second step of the E1 reaction, there is no change in the hybridization state. Now the last point, this E1 reaction, it is most favorable with tertiary and least favorable with primary. Why? You know that the tertiary carbocation are the most stable carbocations. So the tertiary alkyl halide will be easily changed to its carbocation, which is highly stable. And when the ionization with the tertiary alkyl halide will be easier, then the E1 reaction will also be easier. But in case of a primary alkyl halide will not prefer to ionize. Why? Because the primary carbocation is highly unstable. So primary alkyl halide will show maximum reluctance to change to its carbocation. That's why it will also show the reluctance in the E1 reaction. So tertiary alkyl halides easily show E1, and primary alkyl halides, they easily show E2. And what's about the secondary? Secondary alkyl halides, they show both E1 and E2 reactions with equal ease. It depends upon the environment you are providing to the secondary alkyl halides. In case of a highly polar environment, the secondary alkyl halides will get ionized and that they will show E1. And in case of a less polar environment, they will not be ionized and they will show E2. So it depends upon the environment we are giving to the secondary alkyl halides, whether they will show E1 reaction or E2 reactions. So this was the comparison. Let us just revise this in a 1 minute. It is single step, it is two step, it is bimolecular, it is unimolecular, it shows second order kinetics, it shows first order kinetics. In this, hybridization changes from sp3 to sp2. In its rate determining step, there is change of hybridization, but in the first step, there is no change in hybridization. It is most feasible with primary and least feasible with tertiary. It is most feasible with tertiary and least feasible with the primary. So that was the comparison between E2 and E1. Next time we will come up with some new lecture. If you find any problem related to this lecture, you can ask in the comment section. Take care.